Next up, all right, let's finish this section off and talk about scientific notation. This is more kind of a biology, chemistry sort of question, and you'll see these in those classes as well. But here's an introduction and an application of negative exponents, so it's a good place for it to fit in. Scientific notation, all right, all it is an abbreviation of a number. In our class, we don't generally deal with super huge numbers or super tiny numbers. All right, so this is going to be used for numbers when you're trying to figure out, well, how many miles is it from the Earth to the Sun? Right, some millions of miles, some large number, or how many atoms are there, or how small is a molecule. Right, these all have values that are either super tiny or super large. Right, they're not going to generally come up in an algebra class, but right, we can apply our exponent properties to them. So scientific notation is just an abbreviation of a number, and you might have seen this before. All of the abbreviations are going to look like A times 10 to the n. So here's our generic abbreviation. Sometimes they use the old school multiplication symbol in there. I don't like to use that ever, so I'm going to put the dot. All right, so it's going to be some number times 10 to a power. This is going to work because our number system is base 10, which hopefully we're familiar with. What that means, it just means that if I multiply any number that I have by 10, I can just move the decimal place over. And if I divide by 10, I move the decimal place the other way. So when I multiply by 10 to a power, I'm just moving decimal places. I'm not changing, I'm not really changing this number at all. I'm just moving the decimal place in it. Okay, so there is one rule to scientific notation, and it revolves around what we're allowed to use A as. So in our scientific notation problems, we're going to make sure that A must be between 1 and 10. Right, A is allowed to equal 1, but it's not allowed to equal 10. So it has to be less than 10, but greater than or equal to 1. Okay, so I'll put that in here in more of a technical term. So technical definition of this. So A can be greater than or equal to 1, but it has to be less than 10. Can't equal 10, can't equal 1. Okay, so this number has to fall between 1 and 10. All right, and how it's going to work is if I make a very large number, let's say 179 with a whole bunch of zeros behind it. Right, I don't know what this number is, but I know I can abbreviate it, so next time I wanted to use it, if this was a very common number, I wouldn't have to write out all these zeros or remember how many zeros there are. Right? We're going to abbreviate it by finding a place to put a decimal in this number, right, where it turns this number into something that is between 1 and 10. And that's always going to fall between the first two non-zero digits. So between the first two non-zero digits, I can place a decimal. So my A value is going to be 1.79. So this number is definitely between 1 and 10. So the question now is, how many times do I have to multiply by 10, right, to move this decimal all the way back to the beginning of the number? So I have to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 jumps, all right, to move that decimal back to the beginning of the problem. Right, so 1.79 times 10 to the 12th would be the abbreviation of this number. Right, so just to keep in mind, maybe a common mistake would be to make the exponent the number of zeros that you have. That is not always the case. Right? It certainly is the amount of zeros, but it's also, you still have to move that decimal place to where it belongs. So I did have to incorporate a couple other numbers here. So there are actually 12 jumps. It is not always the number of zeros. And so make sure you're always counting all the spaces it jumps, not just the zeros. Okay, so that works for super large numbers. We're moving that decimal to the right, so multiplying by 10 a lot, we'll get that number there, or that decimal to the end. And it also works for super tiny numbers. 0.000000641. Right, these type of numbers, like I said before, would be, you might run into these if you're looking at the periodic table and checking the atomic mass of an element. They're all going to be very tiny and written in scientific notation. Right, so we want to find where can I place the decimal in here, right, to get a number between 1 and 10. And like I said before, it's always going to be between the first two non-zero digits. So, right, between the first two non-zero digits, 6 and 4. All right, so our number is going to be 6.41. That's A. Right, still times 10. And now I want to take this decimal that I put in here and I want to shift it 1, 2, 3, 4, 5, 6, 7, 8 spots to get it back to where it belongs. And I move that to the left. So that's a negative exponent. Okay, so when we have super huge numbers, it should always be a positive exponent, because the only way for us to get this many zeros at the end would be to multiply by 10. Okay, when we have a very tiny number, something that is in between 0 and 1, a very small number, the only way for us to get this many zeros at the beginning of 1 is to raise it to the negative exponent. And this should make sense because we know what negative exponents mean. I mean, this is how you should write it. This is how scientists write it. Even though in our class we don't really like negative exponents, right? Scientific notation is written this way, but we now know that this means this is 6.41, right? If this is raised to the negative 8th power, it really means that that 10 is in the denominator. So we're really dividing by 10 8 times, and when we divide by 10, we move the decimal to the left. So you don't have to write it this way. MathLab probably won't even accept it this way. But now at least we can find this application and understand why scientific notation is written that way. Okay, so right, we can write really large numbers and really small numbers. We should also probably be able to do it in reverse. So let's expand. If I wanted to write this number in expanded form, 2.3 times 10 to the 5th, well, that's not a big deal. We just write down our A value, right, and we move the decimal 5 spaces in the positive direction, so to the right. 1, 2, 3, 4, 5. Put our decimal there, and we can fill in these blank spaces with zeros. So our answer should be 2, 3, 0, 0, 0, 0. So 230,000. Do it with negative exponents as well. 4.71 times 10 to the negative 3rd. Sure, no problem. Let's write down 4.71. I'm going to write it over here because now I know since it's negative, I'm going to want to move this decimal to the left. So I'm going to take it 1, 2, 3 spots. There's my new decimal. Fill in these gaps with zeros. So 0.00471. We can expand scientific notation to know what actual number we're dealing with. And we can contract numbers or abbreviate them. And the last thing that we're going to be asked to do, right, is do some operations on them, actually. So I'll do 2 quick operations, 1 multiplication and 1 division, and that should cover it. Okay, so what if we wanted to 4.7 times 10 to the 5th? 3.2 times 10 to the 7th. Right, so what we're going to need to do right here is we're going to want to multiply these 2 together. Right, and we can do them in separate pieces, just like we did before. Right, but now we're dealing with scientific notation, so it may seem a little bit differently. I got a little calculator out, so you might want a calculator for these problems because we're going to have to multiply 4.7 times 3.2. You could obviously do that on your own, but the calculator can help, so I got my phone right here. All right, so what I'm going to do is I'm going to multiply 4.7 times 3.2. And we end up with, right, these two get us 15.04. Right, so these two multiply to 15.04. Now I'm going to multiply the tens together. Right, these are bases. Right, so what do we do when we multiply terms with the same base? Right, that's right, we add the exponents. So same bases, add the exponents, this will be 10 to the 12. All right, this looks like a great answer, and you're just about right. The problem is, lots of times when we operate on scientific numbers and scientific notation, when we multiply or divide, this final a value doesn't meet our criteria. It's not between 1 and 10, but we can fix that pretty easily. Okay? We can rewrite this. We can move this decimal one spot over. We want to rewrite it in scientific notation, so here, we want to move it here. So this wants to be 1.504. Okay, so if we wanted to write this in this notation, right, this would be 1.504 times 10, because we just moved the decimal point one spot to the right, times 10 to the 12th. Right, and now we can finally rearrange this. 1.504, 10 and 10 to the 12th would be 10 to the 13th power. All right, so not a big deal. We'll multiply the coefficient parts, or the a values, together, multiply the 10 parts and add the exponents, and then make sure that we readjust our a value appropriately. I still need my calculator for the next one. Let's open this up. So this next example, let's do some division here. There's nothing too special here. Let's divide our a values. So 2.7 divided by 4.5. And this will be 0.6 if we did that division. So 0.6 will be the a value part of this. And when we divide, remember, we're just comparing exponents. What are we going to be left over with? So right, we're subtracting 8 minus 3, so we have 10 to the 5th. And again, that's very close to the correct answer, but it's not quite right, because this value 0.6 is not in the correct range. It's not between 1 and 10, so we need to readjust it. We need to write this singular a value, and we need to rewrite it with an appropriate a value. So I need to write this in scientific notation, which is, again, a little weird, but 0.6 is no good. Scientific notation would mean I need my decimal after that. So we can write this as 6, right? But if I write the decimal after it, that would mean in order to get back to where I started, I'd have to move it one spot to the left. Right, so that'd be 6 times 10 to the negative first power times 10 to the 5th. And now we can just rewrite this as 6. Combine these two together, add our exponents. Negative 1 plus 5 would be 10 to the 4th. All right. But we can multiply and divide numbers in scientific notation. It's a little bit unwieldy. It's not the nicest way to work with numbers, but when you're dealing with these huge numbers, right, it sometimes is the easiest. So there's scientific notation.